In this video, we're going to solve a differential equation of first degree using the integrating factor. If you want to use this method, the equation should look like number 1. Notice how the coefficient for y prime is 1, the coefficient for y is a function of x, and all other constants and x terms have been moved to the right side of the equal sign. We call that g of x. The example that we're going to solve today is y prime plus 2y equals e to the negative x. Notice how the coefficient for y prime is 1, the coefficient for y is 2, which is not really a function of x, but it's just as well because it's a constant, so it's fine. And then on the other side of the equal sign we have e to the negative x, so we'll call that g of x. The first step to solving this problem is to create your integrating factor mu. That's given by the formula there in the middle. Mu equals e raised to the power of the antiderivative of p of x dx. In our case, p of x is just a constant 2, so mu will equal e raised to the power of the antiderivative of 2 dx, which is just e raised to the power of 2x. Once we've established that our integrating factor is e to the 2x, we're going to multiply every term from our original equation times our integrating factor, e to the 2x. So in this case, you multiply the y prime by e to the 2x, the 2y by e to the 2x, and the e to the negative x by e to the 2x. And it will look like this. Notice how I squeezed the e to the 2x in between the 2 and the y in the middle term. I did this so that on the left side you might see how this looks exactly like the reverse implicit product rule. And what I mean by the reverse product rule is just that, notice how here on the last line, if you were to just look at differentiating e to the 2x times y implicitly with respect to x, you would end up with exactly what's just above it on the left side of the equal sign. That is, you would end up with e to the 2xy prime plus 2e to the 2xy. And that is one of the secrets to using an integrating factor. After a while, you'll just skip this step and you'll go right down to the end. It always works out to where on the left side of the equal sign, you'll have d dx of your integrating factor times y equals whatever it is that you would have on the other side of the equal sign after multiplying by your integrating factor. Now what we're going to try and do is continue to solve for y. So to isolate that term, we need to multiply both sides by dx. And then we want to integrate both sides. Notice on the left side how the antiderivative and the derivative cancel out, leaving you with e to the 2xy. And on the right side, you'll have the antiderivative of e to the x dx, which is just e to the x plus c. We only need the arbitrary constant on one of the sides, and it makes it easier if you just have it on the right side. And then you can divide by e to the 2x to isolate the y term to get your final answer of y equals e to the negative x plus c times e to the negative 2x. And you can stop there.